Okay, continuing with chapter 6 and section 6.4. All right. How do you name these following ionic compounds? This is calcium. NO3 is nitrate. So it's calcium nitrate. Iron, Fe is iron. The charge on iron is +3 because the phosphate is 3 negative. So iron 3 phosphate. So name each of the following compounds containing polyatomic ions. This is magnesium. This is sulfite. It's a -2. Magnesium is +2. Charges are balanced. So magnesium sulfite. Again, this is magnesium +2. Sulfate is -2. Charges are balanced. Magnesium sulfate. Pb is lead. It's lead-2. If you look here, phosphite is -3. All right. So the charge on lead is 2. Lead-2 phosphite. Okay. Name each of the following compounds. Again, this is iron. If you look at what the charge on iron should be, it will be 3, so opposite. So iron 3 sulfate. Barium, you don't need the Roman numeral parenthesis. This is main group metal. So it's barium phosphite. Nickel, carbonate is -2. Nickel is a transition metal. And so you do need the Roman numeral parenthesis. So it is nickel 2 carbonate. All right. Going into 6.5, molecular compounds. Molecular compounds are formed by sharing of electrons, all right? So here you see carbon, and carbon has 4 electrons, and it's sharing those electrons with 2 oxygens to form carbon dioxide. And here there's only 1 oxygen. And so again, the goal is that you're going to form an octet for both of the atoms involved, or all of the atoms involved. In this case, there are 3 atoms involved, all right? And so molecular compounds are formed between non-metals, all right? So non-metals come together, share electrons, and form molecular compounds. Now here you do need prefixes, right? So if you're talking about an oxide of carbon, which oxide are you talking about? Is it carbon monoxide or is it carbon dioxide? All right, so that's why you do need prefixes here when you're talking about molecular compounds. So molecular compounds form when there are 2 or more non-metals and they're sharing electrons to form what is called as a covalent bond. So the covalent bond is formed by sharing of electrons. Those valence electrons are shared equally, so as to give each of the atoms an octet and stability. All right. So in naming those molecular compounds, the first non-metal is just the element name. So for example, the oxides of carbon. Carbon is just carbon. And then the second non-metal, it ends in the suffix "ide", all right? And then you use a prefix to show how many of each type of atom is present in that molecular compound. So the kind of prefixes used are mono, di, tri, tetra, and then it's all Greek: penta, hexa, hepta, octa, nona, and deca, all right? So this is carbon monoxide, and you don't have to have 2 O's. It's kind of conjoined together here like so. So it's monoxide. Carbon dioxide, all right? NO would be nitrogen monoxide, and so on. Okay. So this is carbon disulfide, nitrogen oxide or nitrogen monoxide, sometimes they call it. It's also a common name is nitric oxide, dinitrogen oxide, sulfur dioxide, sulfur trioxide, sulfur hexafluoride, and so on. Okay, and a lot of them have got commercial uses, as you can see here. So how do you name these molecular compounds? Start with the first non-metal, name it by its elemental name. The second non-metal ends in "ide," and then add prefixes to indicate how many types of each is present. Okay. So NCl3, nitrogen, and then tri, this is chlorine, so it would be chloride, trichloride. Okay, so nitrogen trichloride. B2O3, B is boron, there's two of them, so diboron. Oxide, there's three of them, so tri. So diboron trioxide. Diphosphorus pentoxide, all right? Two P's, P2, and pent is 5, so O5, P2O5, all right? So diphosphorus pentoxide is P2O5. All right. If it is an ionic compound, that first element has to be a metal, all right? Or it has to be the ammonium polyatomic ion. Then it is an ionic compound. If it is covalent, then the first element has to be a non-metal. That's how you distinguish between the ionic compounds and the covalent or molecular compounds, all right? So again, using the flow chart, how do you know it's ionic? No metal, then it's not ionic, all right? If it is molecular, it has to be two or more non-metals, all right? And then we went through this. If it is metal or ammonium, if it's only one positive, then you write the name of that metal or ammonium. And then if it forms more than one variable type of ion, then you're using Roman numerals parentheses. For the non-metals, if it is just a single atom, a single element, then it's "ide" suffix. If it's polyatomic, you use the name of the polyatomic. For molecular, that first non-metal, you're using the element name, and in the second non-metal, you're ending it with "ide." Prefixes are used to describe how much of each type of non-metal is present in the compound. All right, so this would be silicon tetra. There's 4 of those chlorines, so tetrachloride. Remember, the last non-metal name ends in "ide, all right? So silicon tetrachloride, C. This is diphosphorus pentoxide, all right? So diphosphorus pentoxide, C. And this would be dichlorine heptoxide, dichlorine heptoxide, so A. Identify each compound as ionic or covalent and give its correct name. All right, so the first element is a nonmetal, so this is covalent, sulfur trioxide. This is a metal, so therefore this is ionic, barium chloride. Now this is ionic because of the ammonium, and so it's ammonium phosphite. This is again ionic metal, and this is it has variable charge, so you'll have to look at what that charge is on copper. All right, carbonate is 2 and you have 2 coppers, that means copper is 1, so copper 1 carbonate. This first element is a non-metal, so it's molecular, dinitrogen tetroxide. All right, study check. Write the formulas for each of the following and identify what type of bonding is present in each. Okay, so what do we do here? This is non-metal, so that's SO2, sulfur dioxide. Okay. All right, I'm going to take these and copy, put in a new slide. Whoops. Come on. And change the layout here. Oops. Okay. All right, go back here, give myself some room, take this out. Okay, so this would be ammonium, but phosphate is got 3 negatives, so it's going to be ammonium is 1 positive, ammonium is NH4, but you need 3 of those to balance out 1 phosphate, and so it's going to be ammonium 3 and then PO4, ammonium phosphate. All right, potassium chlorate, potassium is K, chlorate is ClO3. All right, and chlorate is got 1 negative, ClO3. Lithium hydroxide, so Li is 1 positive, hydroxide is 1 negative, the charges are balanced, LiOH. Zn, zinc nitride, Zn is +2, zinc is +2, nitrite is 1 negative, so you need NO2 is nitrite, NO2 minus, so you need 2 of it. Okay, sodium sulfate, so Na, and it's plus, sulfate is 2 negative, so crisscross, it's Na2SO4. Okay, so SO2, ammonium, NH4, 3PO4, KClO3, LiOH, Zn, NO2, 2, and Na2SO4. Okay, so coming here to cobalt 4 bisulfite, so that's CO. Bisulfite is okay. HSO3 is bisulfite, okay, and HSO3 is got a negative charge, and so you need 4 of those to balance the 4 positives on cobalt. So COHSO3 4. Cadmium nitrate, CD, and then NO3 2, because cadmium has a +2, nitrate is -1. Okay, so you need 2 nitrates. And then nitric oxide, nitrogen monoxide, so that's simple, NO. Hydrogen peroxide is the common name, H2O2. There's 2 hydrogens, 2 oxygens. Carbon monoxide is CO. Silicon dioxide is Si and O2. Whoops, no, SiO2. And then copper 1 bromide. Bromide is 1 negative, copper is 1 positive, so CuBr. Okay. All right, we will stop here.